Okay, so I hope that you can see me. Let me also connect through Zoom so that you can confirm that you can hear me and everything is okay. So if one of you can connect me through Zoom as well, I would appreciate that. I don't know, there is something wrong with this computer today. I hope that you can hear me. One of you can make a like, that this means that you can hear me. And you just please push the like button, one of you at least. Okay, good. So you can hear me. Okay, we can continue. Unfortunately, probably you cannot ask me questions, but let me start teaching. So here we also want to talk about today about the quadratic equations. By the way, that was a trick that I got like from you. Okay. Okay. Anyway, so let me write the title again. So quadratic equations. This is part 3, yes? Okay, so today we want to talk about how to solve this equation, this quadratic equation in general. And we know that A is not equal to 0. Okay? The method that I want to describe today is not exactly the method that I myself always use, but I want you to know about this method, and that is called the completing square method. Completing the square method. So the reason that it was simple to solve this equation, if I ask you to solve this equation, it was very simple, and we discussed about that yesterday. The reason that it was simple is because this is a complete square on the left-hand side, and I want to calculate x. So if I want to calculate x, I can immediately take the square root from both sides. I would write square root of 4, then I have to put plus and minus here, and the answer becomes plus and minus 2, because I have a square root of 4 equals to 2. And if you remember, we also talked about a problem like this, for example. We have x plus 1 to power 2, and it is equal to 64. So if you remember, we didn't have any problems solving this problem yesterday. And the reason is exactly the same argument. This is a complete square. It is the square of something, and my unknown is inside this complete square. So if I want to find it, I can take the square root from both sides, and then I can find my x. So if you remember yesterday, we solved some similar problems to this. And then we say that, okay, x plus 1 is equal to plus or minus the square root of 64. And then we say that x plus 1 is equal to plus or minus 8. And then if you remember, I told you that we have to consider two possibilities. Either x plus 1 is equal to positive 8, and then from here you conclude that x is 7, or you conclude that x plus 1 is negative 8, and then you see that x is equal to minus 9. So anyway, my point is that the reason that solving these quadratic equations was simple is because the left-hand side is a complete square, okay? And by the way, this is quadratic because you see the highest power for the variable is 2, and this is also quadratic because if you use a squaring pattern and raise it to power 2, the first term becomes x squared, so this is also a quadratic equation. So it seems that if I have a complete square on the left-hand side, I am done, okay? And then you need to learn how to make the left-hand side to be a complete square, and then immediately you can use this trick to find your unknown. So that is the goal of today's lesson, okay? And I just want to teach this to you, and then I will end the meeting. So I know it might be some of you have some questions. I don't want to teach that much today. Okay, so let me start with example. So use the method of completing the square to solve the following equations. Okay, so number 1, x squared plus 4x minus 5 is equal to 0. Okay, so my goal is to solve this equation, and then you see that this is a complete generic equation. If I compare this equation with that equation, you immediately realize that your a is equal to 1. Yes, because the coefficient of x squared is a, and here I have 1, and b is 4, and c is negative 5. Okay, later we will learn a formula. It's called PQ formula, or I will also teach you what is more popular outside Sweden probably, and that is ABC formula. So I will tell you, if you know A, B, and C, and if you know that formula, how can you use the formula to find the answers? But it is a crucial part of your lesson because one can just memorize the formula and solve the equation. In order to prevent this, so that I can make sure that you understand what is behind that formula, I want to teach you the completing a square method, which is also one part in the book. So it is more or less mandatory for you to learn this trick, even though later you can just a formula to solve it. Okay, so it's very important to understand this method. Okay, so how should I solve this problem? If I compare this one with this equation, the reason that I cannot solve this equation directly is because on the left-hand side, I do not have a complete square yet. Okay, so I need to remind myself about the squaring pattern. What was a squaring pattern? So let me write it here. So if I have a plus b squared, this is a squared plus 2ab plus b squared. So we learned a lot. If I have this pattern, you can go back when I was teaching you factoring polynomials using the squaring pattern. We learned that as soon as we realize that this is the pattern, I can go back and write it as a complete square. Of course, it is clear here that this is in this form, it is not still a complete square. Yes, for having a complete square pattern, you remember what was the need, what we need. We need to have 3 terms. Okay, we also have 3 terms here. But I need to have 2 complete squares, and I need to have the middle term written appropriately, meaning that the middle term is 2 times the square root of the first one times the square root of the last one. So the only thing that I have here is that I have 3 terms. I have only 1 complete square, and that is x squared. So the idea is to add or subtract or divide something to both sides in a way that the left-hand side makes a complete square pattern. Okay? So the trick that we use is we move this term to the right. Okay? So what happens? It becomes x squared plus 4x. I move minus 5 to the right, it becomes positive 5. Okay, so here I have 2 terms, x squared plus 4x. I want to add something to the left-hand side so that the left-hand side becomes a complete square. I mean, by adding that number or expression to the left-hand side, I want to make the left-hand side follow the squaring pattern. Okay, and that is not hard to understand. So what number is missing from here? I need 2 complete squares. 1 complete square is here. I need another complete square in a way that when I look at these 3 terms, it becomes a complete square on the left-hand side. So let me just write it down. This is something I can tell you how to find it, but let me write first the number here. I add 4 to the left-hand side. In order to keep the equality, I have to add the same 4 to the right-hand side. Okay? So let me just explain. I'm trying to find the x from this equation. I am teaching you this actually. You just need to learn. I move the constant term to the right-hand side. It was negative, now it becomes positive. Now I think, what can I add to the left-hand side so that when the addition is done, the left-hand side becomes the complete square of an expression. And that number is not hard to guess, and that is 4. I decided to add 4 to the left-hand side. I have to add the same 4 to the right-hand side in order to be able to keep this equality. Okay? But now if you look, if I ask you what is this one, you immediately realize that I have 3 terms. 2 of them are complete squares. But then I go to a scratch paper. I take the square root of the first one, it becomes x. I take the square root of the second one, it becomes 2. I multiply them, and I multiply it by an extra 2, as I usually do. It becomes 4x, and then you see that this 4x is exactly what is in the middle. So this, after 4 is added, follows exactly the squaring pattern. So now I can collect it back into the form of a complete square. Do you remember? I put a pair of brackets with the power of 2 on top, and then I take the square root of this one, and then the square root of this one. And because this is positive, I write this. On the right-hand side, 5 plus 4 is 9. Okay? Now, I don't think you have any problem solving this equation. And this equation, we learn how to solve. It is very similar to this equation, yes? So here, let me clean, not to confuse you. So I collect everything back into the form of a complete square. Then I do what? I take a square root from both sides. It becomes plus and minus the square root of 9. And then a square root of 9 is 3. So let me write it here. It's x plus 2 is plus or minus 3. And then I have 2 possibilities. Either x plus 2 is positive 3 or x plus 2 is negative 3. Yes? So this implies that I move 2 to the left, I move 2 to the right, it becomes negative 2. Negative 2 plus 3 is just simply 1. So this is one of my answers. And then I move 2 again to the right, it becomes negative 2, and negative 3, it becomes negative 5. So these are possible answers to this equation. Okay, we can check. If I take 1 and put it here, 1 to the 2 is 1. 4 times 1 is 4. 4 and 1 becomes 5. Minus 5 is equal to 0. So that is correct. I will take the other one, minus 5. I put it here. Minus 5 to the 2 is 25. 4 times minus 5 is minus 20. Minus 20 and 25 is 5. Minus 5 is again 0. So the answers that I've got are exactly correct. So the point is this. Let me just review a little bit. An equation is given to you. The equation that I can solve without any problem are those type of equations that I have a complete square on the left-hand side. So my goal is to ask myself, can I make the left-hand side of this equation into a complete square? And this is always possible. This is the good news, okay? So how should I do that? You need to remember this algorithmic way of doing it, okay? So first, you need to move the constant number to the right. So you have another equation that you have a constant number to the right. The tricky part is which number should I add? Sometimes this number is so easy that you can immediately guess. But if you cannot guess what that number should be, I tell you what to do. You need to take this number in the middle, you go to a scratch paper, you divide this number by 2, it becomes 2, and then you square it, it becomes 4. And that is the number that you have to add. So the number that you have to add is the middle number divided by 2 and then squared. This number that you get is the number that you have to add in order to make the left-hand side a complete square, okay? So that's always working. I will give you, of course, more examples. And then everything is going back to the previous lesson, okay? So what I do, I use my scaling factorization, I collect it back into the form of a complete square, and then I take a square root from both sides, and then you know what to do. Exactly, this goes back to the lesson that we had before. Yes? I hope that this is clear, but let me give you more examples. Let me do one simple one again. X squared plus 12x minus 13 is equal to 0. So this is number 2. Okay, we want to use the squaring, completing a square method to solve this equation. Again, now that we learned that, we do it algorithmically. What I need to do, I want to make the left-hand side to be written as the completed square of an expression. So algorithmically, I move the constant term to the right. So this becomes x squared plus 12x is equal to 13. I go to a scratch paper. This is the time that I have to add something to both sides in a way that the left-hand side becomes a complete square. Okay, I told you the trick. The trick is to divide this middle number by 2. It becomes 6. And then square it. It becomes 36. So your magic number that you have to add to both sides is actually 36. So I would add 36 to both sides. I have to add to both sides, otherwise this equality will be spoiled, yes? So it becomes 13 plus 36. And then if you have done everything as I told you, be confident. This is always a complete square. How should we check that? First of all, there are 3 terms involved. 2 of them are complete squares. And then, is it really the case? Let me check in the scratch paper. I take the square root, and then I multiply it by 2, always. 2 times x times 6 is 12x, and exactly, you see, 12x is the number in the middle. Okay? So what I need to do now is to collect this term. So it becomes x plus 6 to the power of 2. Yes? The first one to the 2. 2 times the first one times the second one is exactly the middle one. And the second one to the 2 is this one. And then 13 plus 36 is 49. And then we are done, yes, because the left-hand side is a complete square, so I take the square root from both sides, yes? So it becomes x plus 6 is equal to plus and minus square root of 49. And then we know what to do. Here, of course, the square root of 49 is 7, so it becomes plus and minus 7. And then from here, I have to divide my problem into 2 problems, yes? One with the positive sign and the other one with the negative sign. So it becomes x plus 6 is equal to 7, or x plus 6 is equal to minus 7. But I think you can immediately move this in your head to the right. It becomes negative 6. 7 negative 6 is just 1. So this becomes x equal to 1. And then here, I move 6 to the left. It becomes negative 6. Negative 6, negative 7 is negative 13, yes? So these are the answers that we get. So this is the trick. Of course, this problem can be a little bit harder. If you see the examples that I have provided on the board, in both of them, if I ask you what is the coefficient of x squared, both here and in that example, the coefficients are actually 1. Okay? So the harder problem is that what happens if the coefficient here is not 1. But before going to an example in which the coefficient is not equal to 1, the other possibility, the other thing that makes this problem simple is that in this example and this example, I give you the middle one as an even number. Even number, it's easier. Why? Because when I want to find my magic number here, I divide the middle term by 2. If this is not an odd number, if this is not an even number, when I divide it, I have to work with fractions. So before going to the hardest possible case, that I have some number here, let me teach you what will happen if you have an odd number, or any other number, by the way, here. Don't worry about that, okay? So you need to learn how to work with fractions. You're not allowed to keep approximate values, okay? So let me give you another example here. So number 3, for example, let us solve this one. X squared plus 5x plus 4 equals to 0. I want to solve this equation. Okay? Okay, what we need to do is as before. First of all, is it a complete square? No. I have 3 terms, that's correct, but I have, by the way, I have 2 complete squares. Be careful. I have 2 complete squares, but this is not a squaring pattern. Why? Because if you go to scratch paper, take the square root of this one is x, take the square root of this one is 2. If you multiply them and you multiply it by an extra 2, as always we do, it becomes 4x. And you see that 4x is not in the middle. So even though I have 3 terms, I have 2 complete squares, but it is still not a squaring pattern. So I cannot collect this left-hand side into the form of a complete square. I have to use this trick that I told you here. So what I should do, again, the algorithm is the same. I move the constant number to the right. The constant number is positive 4. When I move it to the right, it becomes negative 4. So this becomes x squared plus 5x is equal to negative 4. Okay, and then you need to go to a scratch paper to calculate what you need to add to both sides in order to make the left-hand side a complete square. And I told you the trick. The trick is you go to scratch paper, you divide the middle number by 2, but you see 5 divided by 2 is 2.5. Learn to work with fractions. Okay, so even though in this case it is complete, I can write 2.5. In this case, it is not actually wrong to write 2.5, but I want to encourage you to learn how to work with fractions. So I divide the middle number by 2, it becomes 5 over 2, okay? And then I square it. As I did before, yes? You see here, I divide my middle number by 2, the answer was 6, and after that, I squared the number 6. Here, I divide 5 by 2, because this is going to be a fraction, this is going to be decimal number, I will keep the fraction 4. And then I square it. When I square it, it becomes the first one to the 2, the numerator to the 2, the denominator to the 2. So my magic number is this number. This is the number that I have to add to both sides. Okay? So I will do that. I would write x squared, and then I would write 5x. Then I would write 25 over 4. But what I need to do, I need to add 25 over 4 to the right-hand side. So you see, nothing is actually very strange here. The only thing that I am doing is just working with fractions. Okay, the left-hand side is now a complete square. So I put a pair of brackets and I put a second power on top. I take the square root of this one is x. I take the square root of this one, it is 5 over 2. And then I have a positive sign here, so I put a positive sign here, okay? And then on the right-hand side, I want you to know, hopefully you know how to calculate these simple fractions. So what you need to do is to write, the common denominator is 4. The denominator of minus 4 is actually 1. So 4 divided by 1 4 times, and if you multiply it here, it becomes minus 16. And then I have a plus sign. And 4 divided by 4 1 times, 1 multiplied by 25 is just 25. Okay, and then let us simplify it one more step. So it is x plus 5 over 2 to the 2. On the right-hand side, I have 25 minus 16 is 9, and 9 divided by 4. Okay, let me continue here. I just remove this scratch paper, we don't need it anymore. And then we are done. My goal was to write this as a complete square. 1 point. I am not factorizing. Might be some of you are a little bit disturbed saying that, okay, this is a fraction. We were supposed to factorize on the set of integers. Yes, the goal is, again, is not factorization here. Okay, so don't get confused. Still, I am using the completing the square technique to write that expression as a complete square. My goal here is not to factorize anything. My goal is to write the left-hand side as a complete square. It is a factorization, of course, on the domain of rational numbers. Yes? Forget about these details. The goal is just to write the left-hand side as a complete square. Okay. And then after that, it's clear. I take the square root. It becomes x plus 5 over 2. On the right-hand side, I put plus and minus. Then I take the square root of 9 over 4. Okay, and then one more step. It's plus and minus. Do you remember I told you a formula yesterday? So if I have a square root of a over b, if a and b are positive numbers, then you can write the square root of the numerator divided by the square root of the denominator. Okay, so here this becomes a square root of 9, which is of course 3. Square root of 4 is 2. And then from here, I divide my problem into two parts. One considering the positive sign, one considering the negative sign. So I have x plus 5 over 2 is equal to 3 over 2. So then what I do, I move 5 over 2 to the right. So it becomes 3 over 2 minus 5 over 2. But the denominators are the same. 3 minus 5 is minus 2, but minus 2 divided by 2 is just minus 1. So let me write here. One answer is minus 1. Okay? And then I have x plus 5 over 2. The other answer is minus 3 over 2. So what I do, I move 5 over 2 to the right. It becomes minus 3 over 2 minus 5 over 2. And this becomes minus 8 over 2. And when I divide that, it is minus 4. So the other answer is minus 4. Okay? So the only difference between this new problem and the first two problems was that this was an odd number. So when I divide, I get a fraction. Of course, in this case, 5 over 2 is 2.5. If you manage to do it with your calculator and whatever with decimal points, that's completely okay, because there is no difference at all between 5 over 2 and 2.5. Yes, that's up to you. But I want you to learn this. It's inevitable. You have to learn how to work with fractions at the end. Okay, so this is why I want you to practice and learn working with fractions, which of course shouldn't be hard at all for you at this level. Okay, so let me give you another problem. And the reason that I am telling you that you need to get used to working with fractions is because the hardest part of these type of problems is when that you don't have this coefficient is not equal to 1. Okay, now let me give you an example of that type. But before doing that, let me give you one more example of this type first. Okay, so let me write it in this form. Number 4, I give you this example. X squared minus 4x and then minus 7 is equal to 0. Okay, so assume that we want to solve this. Okay, because you know what we have to do, let me just do it quickly. So I move the constant number to the right. It becomes positive. I go to scratch paper or I do it in my head. I'm supposed to divide this middle number by 2. It becomes minus 2. And then square it, it becomes positive 4. So my magic number that I have to add to both sides is 4. So I add 4 to both sides. It becomes this. But then, of course, immediately you realize that this is a squaring pattern. So it becomes x minus 2 this time to the power of 2. Yes? Everybody hopefully agrees with me. Okay, and on the right-hand side, it becomes 11. So why this is the case? Because if I square it, the first one to the 2 gives me the first term. 2 times the first one times the second one gives me exactly the second term. And then plus the second one to the 2 gives me this one. So, and then 11 plus 7 plus 4 is 11. And now I have to take square roots from both sides, yes? So it becomes x minus 2, it's equal to plus and minus square root of 11. Okay? This is a little bit different from the problems that I have presented so far. Square roots of 11 is an irrational number, so you are not allowed to put it in the calculator and put an approximate value there. You have to keep and work with the square roots of 11, okay? So it means that I stop here. I cannot do anything, but I am looking for x. I am not looking for x minus 2, so I move 2 to the right-hand side, so it becomes positive 2, and then either positive square root of 11 or negative. You can keep it in this form, but I want you to understand what's the meaning of this. The meaning of this, if I ask you how many answers I got here, you would say 2. One of them is 2 plus square root of 11. This is one answer. And the other one is 2 minus square root of 11. That is the second answer. Of course, in this case, if you write it in this way and just put it in a box, that's okay. But if someone asks you what is the meaning of this symbol here, you say that this is a short way of writing these two, okay? And this is the exact. If I ask you calculate up to some decimal points, then of course you put this number in your calculator and add it to 2. But other than that, you have to keep it in this exact form. Okay, so this example tells you that this is not always the case that you are facing good numbers. No, you might face some square root numbers there. Okay, now there's no much time left, so let me finish this lesson. At least we can come. If you have questions, we can talk about this on Friday. But let me now give you an example. So that this first coefficient is not equal to 1. Okay, so let me write it in this form. I would say 2x squared minus 6x and minus, no, 6 is not here. Okay, let me give you this example first. So it's minus, minus 5 equals to 0. Yes? Okay, so we want to solve this equation first. Now, might be this is not a very good example. I need to make it a little bit simpler for the first time. Let me write it plus 4. Okay. So I want to solve this equation. If I want to solve this equation, the first thing that comes to mind, now you see that the coefficient of x squared is not equal to 1. Yes? So what I need to do, in the previous time, the first thing that I do is just move the constant term to the right. Okay? This is correct if this coefficient is equal to 1. If the coefficient is not equal to 1, before moving the constant term to the right, you have to divide everything by this coefficient. Okay? And then follow the same rule. Yes? Because then immediately it becomes a problem in which the x squared coefficient is equal to 1, and you know how to do it. Okay? So here, when I see this, I immediately see that this coefficient is not equal to 1. Instead of moving this constant coefficient to the right immediately, there is a step before that. And that step is to divide everything by this. Okay? So what you do, you divide by 2, it becomes x squared. You divide this by 2, it becomes minus 3x. And you divide this by 2, it becomes positive 2. And then the right-hand side, 0 divided by 2 is 0. So you reduce your problem to a problem that you already know how to solve. Yes? So that is the only extra step that you need to take care of. So I just do this. Now everything is back to the normal. I have a quadratic equation whose this coefficient is 1, so I just move the constant number to the right. And then what is my magic number here? I go to scratch paper, minus 3 divided by 2, and then square it. It becomes 9 over 4, yes? So I add 9 over 4 to both sides. And then collect the terms as before, so it becomes x minus 3 over 2 to the 2. Okay, and on the right-hand side, let me do this in my head. 9 over 4 added to minus 2 can be written as minus 8 over 4. That's another name of minus 2. Minus 8 over 4 plus 9 over 4 is just simply 1 over 4. And then I take the square root, yes? The square root of this one becomes x minus 3 over 2. I put plus and minus. Don't forget to put plus and minus. And this is a simple number. You can do it in your head. The square root of 1 over 4 is nothing except 1 over 2. And then you know that I have two possibilities. X is minus 3 over 2 is 1 over 2. X minus 3 over 2 is minus 1 over 2. If I want to solve this, let me do it in my head. Minus 3 over 2, I move it to the right, it becomes positive 3 over 2. Positive 3 over 2, positive 1 over 2 becomes positive 4 over 2. But 4 over 2 has a better name, yes? So it is just 2. The same story here, minus 3 over 2, I move it to the right, it becomes 3 over 2. Minus 1 over 2, it becomes 2 over 2. It got a better name, so it's just 1. So these are the answers. Okay, so the only thing that you need to be careful, if this coefficient is not equal to 1, there is an action that you need to do before that, before moving the constant term to the right. Of course, if you want, you can move the constant to the right first and then divide. There is no difference. But I just want you to know that there is an extra step. Division by this constant is the extra step that comes into the problem. Okay? It doesn't matter, by the way, if you divide first and then move the constant term to the right, or move the constant term to the right and then divide by 2. But the point is that you have an extra action that you need to take care. Okay? So let me give you another example, which is the last example for today, and we will end this meeting. And if you had some questions and you couldn't ask me in this session because of this way of streaming online, so you can keep your question and ask everything on Friday, when we just will have the normal Zoom lesson. Yes? Okay, so let me give you another example. Let me write this. Number 6, let me write 3x squared. Let me work with fractions here. 5x. And then here, let me write minus 6 is equal to 0. I want to use the complete square method, completing the square method to solve this equation. Okay? So here, immediately you see that you have a quadratic equation, and then this number is not equal to 1. So you need to remember that you have to divide by 3. Okay, it doesn't matter if you move 6 to the right and then divide by 3 or the other way around. So let us stick to the same principle that I did in that problem. So as soon as I see this is not 1, I divide everything by 3. This divided by 3 is just simply x squared. And then this divided by 3 is 5 over 3x. This divided by 3 is minus 2. And on the right-hand side, 0 divided by 3 is just 0. And then, of course, this is a normal equation. The unfortunate thing here is that this fraction, you have to work with it. And then you cannot write something here for this because this is, you cannot write it as a decimal point number. So you have to work with fractions. This is why in the previous example, I told you that you need to get used to working with fractions. Okay, and that is not a big deal. So I have a quadratic equation. The first coefficient is 1, so the standard way was to move the constant term to the right. So this becomes x squared plus 5 over 3x is equal to 2. So let me write these detailed calculations here for you. Okay, so I want to find my magic number so that when I add that number to both sides, the left-hand side can be collected back into the form of a complete square. And I told you the trick. What was the trick? I told you that take the middle number. This middle number is this one. It's a little bit annoying. And then divide this by 2. Let us see what happens. You cannot put this in your calculator unless you switch your calculator into fraction mode calculation, yes? So if you remember, I told you how to do this in Math 1C. I give a denominator equal to 1 to this, and I multiply these numbers which are far away from each other and put it in the numerator. So 1 times 5 is 5. And then I multiply these numbers that are close together and then put the answer in the denominator. So that's 5/6. So when I say you divide this number by 2, it is simply multiplying the denominator by 2. So the answer is 5/6. And that the number that I need to add, my magic number, is this number squared. So this number squared is 25/36. So this is your magic number. So you need to add this number to both sides. So it becomes x squared plus 5/3 x. This is the number that I add to both sides. Okay? And then the rest of the problem is as before. So, but you need to be good in calculation with fractions, or of course you can switch your calculator into fraction mode if you're supposed to use your calculator. Okay, so let me just do it. On the left-hand side, I can do it in my head. Yes, instead of 2, what can I write? The denominator should be 36, so it is 72/36. Yes, it becomes 2. So now the denominators are the same, so I add the numerators. So it becomes 97. Yes, so this becomes 97. And then the denominator is 36. But if I ask you what is the left-hand side, this is always the case. The left-hand side, if you follow exactly what I told you here, don't be worried. This is exactly the complete square. How should I write the complete square here? I take the square root of the first one, it becomes x. Take the square root of the second one, which is 5/6. And then because this one has positive, so this is the positive version of a squaring pattern. Of course, you can always check. The first one to the 2, 2 times the first one times the second one is this middle one, and the second one to the 2 is this one. And then you know what to do. I take the square root from both sides. The left-hand side becomes this. The right-hand side becomes plus or minus the square root of 97 is not a complete square. I have to write it there. Don't do approximation here. But the square root of 36 is just simply 6. So this is why I put it 6. And then I am looking for x. So I move 5/6 to the right. So it becomes negative 5/6. And then I have plus or minus square root of 97/6. And that is your answer. But I want always to write it more beautiful. So instead of having 2 fractions, so you see people, because the denominators are the same, so I combine them with writing the common denominator, and this is -5, and this is plus or minus, and this is the square root of 97. Okay, so this is the answer. So this is something that you need to get used to, even though most of the problems in the book are those problems that when you solve, you get very kind numbers. But this is not always the case. You need to get used to working with these sometimes strange numbers, of course. And if I ask you approximate the values, then only then you are allowed to put this in your calculator. But be careful. How many answers I got? Again, 2 answers. This is a compact way of writing this. I got 2 answers. One of them is -5 plus the square root of 97 divided by 6. This is one answer. And the other answer is -5 minus the square root of 97/6. So these are 2 answers. So you see, I would say that probably this is the hardest possible example for solving these quadratic equations, and this is not hard. You need to get used to working with these numbers. Okay. Sorry that I couldn't actually be on time a little bit. I don't know what is the problem with the laptop today. So I know that some of you might have some questions. You were not able to ask these questions from me, but yeah, just write it somewhere so that you don't forget about your question. And on Friday, I will answer all your questions first and then give you some other examples that you can work on yourself, okay? Okay, so good luck and bye-bye. Bye-bye.